In Lesson 5.2, we have one more example 6 that you may not have had enough time for in class. A vocab word that we need to be introduced to is called a conjugate. This is when we have something like a plus root b times a minus root b. Or they don't have to be multiplied, but we call the conjugate, it's like the opposite. So the 1 plus root 5's conjugate would be 1 minus root 5. Now I'll see why we use these here. When you have a denominator, or a fraction if you will, there should never be a root in the denominator. Now we know we can handle that with Desmos or a calculator. We can sure get an approximation, but in order to get radicals out of the denominator, we would need these conjugates for problems like example 6. So here we have 1 over 2 plus root 5. I don't like this radical in the denominator, but I can't just throw it away or subtract root 5. This bottom piece is a unit. So I'm going to take 1 over 2 plus root 5, and I'm going to multiply that denominator by its conjugate. So I'm going to multiply by 2 minus root 5 on the bottom, but whatever I do to the bottom, I have to do to the top. So we still need to follow the rules. Let's put parentheses around both of these. Now 1 times 2 minus root 5 will just be 2 minus root 5. But in the denominator, we would use our rainbow technique or our distributing technique. So 2 times 2 would be 4, and 2 times a negative root 5 would be negative 2 root 5. Then now I have a root 5 times 2, they're both positive, so it would be a positive 2 root 5. And a positive times a negative makes a negative root 25, because 5 times 5 makes 25. Now we know our numerator isn't going to change, but we have some combining in our denominator to do. Our 4 will stay out front. We have a negative 2 root 5 and a positive 2 root 5. Those are going to cancel. We also know the square root of 25 is 5. So we have 4 minus 5, which is negative 1. So our final answer is 2 minus root 5 over negative 1. We could also divide each of these by a negative, and so it could be written as the negative 2 plus root 5. That might be your simplest answer there. Now the triads have 2 other examples that we could look at. So on this second one, or the first one we'll do, we have 5 minus root 2 on top, but that's okay. 2 minus root 3 is not okay. We do not like radicals in the denominator. So the best way to get rid of that is to multiply that denominator by the conjugate. Remember, conjugate is like this opposite sign change. Everything else stays the same. Now, whatever I multiply that denominator by, I have to multiply the numerator by. Super important that we put parentheses around everything, though, so we do some multiplying. All right. I have a little more work to do here on both the numerator and the denominator. 2 times 2 would make 4. 2 times root 3 is 2 root 3. Negative root 3 times 2 is negative 2 root 3. Now that should always happen. These should always be the opposite of each other. That's why we make it that way, to get rid of that radical. And then I'll have minus root 9. That's my denominator. I'm going to go ahead and multiply that numerator in the same way. So I have multiplied all 4 terms out in the numerator, and now I'm going to simplify my answer, especially in the denominator. The top has nothing that can be reduced. We just have to write them all out. The denominator, however, we've got a 4 here. These cancel, and the square root of 9 is going to be 3. So 4 minus 3 is 1. I don't have to write a fraction over 1, but my final answer would be basically the numerator, and that should be a plus sign there. So to finish off the video, at this point I want you to consider the quiz question that this video goes with. If you were to be asked, what conjugate should we multiply this denominator by in order to get rid of that root x, what conjugate would we be considering? So take a second to answer that video question, or this question under the video. What would the conjugate be of this denominator that we need to multiply by? All right, so to get rid of this root x, I have chosen to multiply by 1 plus root x on both the numerator and the denominator. So to get my numerator simplified, I'd multiply that negative 4x through times 1 and that negative 4x times root x all over. I would need to do the distribution here. Once again, after you look at those steps, and you may need to pause the video to make sure you know where all of those pieces of the denominator came from, we always find that if we do the correct conjugate, these two middle terms cancel out. We also know the square root of x squared is just x. So our final answer will look like this. And we cannot combine the 1 and the minus x, so we would leave it, but we have definitely gotten rid of that square root in that denominator.